Welcome back to geometry. We are at section 1.8, the coordinate plane. Before we start this new lesson, let's finish up the few problems we have up the top. This first problem is going to involve the angle addition postulate. And let's grab my pen and we're ready to rock and roll. So when we look at this angle here and we add up this angle here, these two angles are going to add up angle COE. So angle 1 plus angle 2 will equal the entire angle. So we're going to use algebra to solve that. We have 5x minus 18 plus 2x plus 6, and that's going to equal 72 degrees. And so 7x minus 12 equals 72 degrees, 7x is equal to 84, and x is equal to 12. Remember that once we find x, we have to then plug it back in to find each interior angle. So when I plug in 12 for x, I get 60 minus 18. That's going to give me a 42 degree angle. And then 12 times 2 is 24, plus 6 is 30. And always check to make sure that these two angles add up to what was given, which was 72 degrees. And yes, everything checks out. On problem 10, so again, on 9, excuse me, again, this was the angle addition and then postulate. That was the rule that we used in order to solve this problem. This relationship in geometry is always called a linear pair. And so remember that a linear pair are adjacent supplementary angles. So we're going to take this angle plus this angle, and it's going to equal our straight line, which is 180 degrees. So x plus 100 plus 2x plus 8 equals 180 degrees. 3x equals 72, x equals 24. When I plug 24 back in for x, I get 124 degrees here for this angle, and this angle is going to give me 48 plus 8, 56 degrees. Again, always check and make sure these two angles add up to 180. They do. Alright, next we have if r is between f and m, then fr plus mr is equal to fm. Sometimes it helps to draw out so we can see exactly what's going on. So we have f and m, and r is between. So we're taking this segment plus this segment equals the entire segment, which is fm. And that's clearly going to be segment, add, and postulate. Next, NT is a segment bisector of PQ. So first, draw PQ, because this is the segment that gets bisected. Then it gets bisected by NT. Let's make NT go diagonal. There's N and there's T. And what it does is, we still have this point in the middle called H. H becomes our midpoint, so these two lengths are the same, and therefore H is the midpoint of PQ. So the rule that allows us to do this, or what we actually drew up, was a segment bisector. So we're going to say definition segment bisector, and then as a result we could say that H is the midpoint of PQ. If something is congruent, then it's always going to be equal as well. That's going to be definition of congruence. If ray SE bisects angle KSM, so let's show angle KSM. We'll put K here, we'll put S here, we'll put M down here, and let's extend the arrows. And we say that ray SE is going to cut this angle in half. That means these two angles are the same. There's ray SE. Then angle KSE is equal to angle ESM, and what we just have there is called definition of an angle bisector. With the algebra review, First thing that we should do here is we want to add 12 on each side. So we're going to try and solve for x. We get 5 over 7x equals 30. We multiply both sides by 7. We end up getting 5x equals 210. And then divide both sides by 5. X would be equal to, how many times is 5 equal to 210? That'd be 4, 20, 42 times. On problem 2, the goal again is to eliminate all these fractions. Let's times both sides by 12. And I chose 12 because 4, 3, and 12 all go into 12. 4 and 12 reduce to 1 and 3. 3 times 3w is 9w. No more fractions. 3 goes into 12 4 times. 4 times 2 is 8. No more fractions. And then these 12s cross out and we get 7. 9w equals negative 1. And then divided by 9, w equals negative 1/9. On problem 10, I would cross multiply 5 times 3w plus 1 equals 60. 15w plus 5 is equal to 60. 15w is equal to 55. Divide by 15. And then divide by 5. Divide by 5. You get w is equal to 11 over 3. And we can leave it like that, or if you really want to, we can then convert it to a mixed number. 3 and 2/3. Either way is fine. Alright, to the square roots. We're only going to do a few of these. When I break down square roots, let's take rad 80. I can think that 80 breaks down to 10 times 8. 8 breaks down to 4 times 2, and 2 is prime. 10 breaks down to 5 and 2, and 2 is prime. And then 4 breaks down to 2 and 2, and 5 is prime. So what I have here is I have 5 times 2 times 2 times 2 times 2. Now, for every pair that I have, I can pull out one of these. So I get to pull out 1, 2. I pull out a second 2. So now I have 2 2's in front and then 1 5 left underneath. 4 out of 5. The coordinate plane continues. The distance formula. Hopefully by now you recall what this formula says. It's going to be x2 minus x1 squared plus y2 minus y1 squared. And then remember we have to take the square root sign. Remember the sign in the middle is a plus sign. Midpoint formula, we're going to take the average of the x's, x1 plus x2 over 2, comma y1 plus y2 over 2. Alright, we're not going to graph all these. Let's just go with what they want us to do. So what is the distance between A and B? We're going to show A at 7, negative 3. We're going to show B at negative 6, negative 3. We can draw that segment in. There's our segment. Let's label this. So this was point B. This was our A point. And they want us to find the distance between A and B. Now, we can use this long formula if you want, but it's more work than necessary. Since this is a horizontal line, let's just count over. So we count from A to B. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 units. Much easier than plugging that into the distance formula. Also, for point E, we can do the same. E is going to be 7, 2. Alright, so here's point E. Let's create a right triangle. Now, in geometry, we can't ever assume anything. However, we can draw the conclusions from what we see. So, one conclusion that I can make is that since the slope of this line is going to be 0, right? We have a slope of 0, and the slope of this line that runs up from A to E is going to be undefined. Well, what has now just happened is that these slopes are negative reciprocals, or also known as opposite reciprocals. That means the two lines are perpendicular, or upside down T. So let's put a 90-degree angle here. Now that we have created a right angle, let's create a right triangle. So next, our goal is to find the distance between B and E. Let's draw that in. So there's segment BE. so why did I go through all this trouble to create this right triangle? Because really, one thing that I could do is I could take our B point, which is -6, -3, and then our E point is 7, 2, and then I can use this long formula. And if you want to do it that way, great. I think an easier way is to say that this length of the base of this triangle is 13, the height is going to be 5, and so now I can do a squared, which, let's make a 13 squared plus b squared equals c squared. And b squared is going to be 5 squared, and c squared is going to be the length of segment BE, and then squared. So we end up getting 169 plus 25 is equal to BE squared. And then remember, we have to take the square root of each side. So that gives us 194. Now what's nice about 194 is this breaks down to 92, or excuse me, to 2 and 97. Both of these numbers are prime. So we don't have to break it down further. We can just leave it as rad 194, and then this must include our units. Next, we're asked to find the midpoint. And so the first problem is easier than the following two. This is x1, y1. This is x2, y2. We're going to plug this in to our formula. X1 plus x2. So 0 plus 6 over 2, comma, 2 plus 4 over 2. We end up getting 3, comma 3. That's our midpoint. Number 8 involves a little more work. We have a plus 3a plus 2 all over 2, comma 3 plus -1 over 2. This gives me 4a plus 2 all over 2, comma 2 over 2. 4a plus 2, these share a 2. We're going to pull a 2 out, and we get 2a plus 1. And all over 2, comma 2 over 2 is 1. Back from algebra, we should remember that these 2's can cross out. So the answer is going to be 2a plus 1, comma 1. Alright, the next question is challenging, to say the least. If we were to scroll up and graph this point, let me change my color again. So if we were to graph 4, -6, let's put that point here. This is my midpoint. And then I would graph 2, -3. This is my A point. Well, some segment that we've drawn in, because remember, it's telling us that the midpoint of M is between A and B. So this segment's going to come down, hit M, it's going to keep going, and then somewhere down here, it's going to hit B. But we don't know the x, y coordinates of B. So that's what we're being asked to find. So we have to work backwards. And here's why. We're given the midpoint. So I'm going to stick with x1 plus x2 over 2, comma, y1 plus y2 over 2. Now remember that we're given x1, y1, and for B, we don't know what x2, y2 is. So it's unsolved. We're not sure yet. So this is our question mark. Let's insert in, or substitute 2 in for x1. Let's just cross out x1, we'll put 2. And let's cross out y1, and we're going to put in -3. Now remember that it's going to be 2 plus x2 over 2 is equal to our midpoint value. The x is 4. I'm going to put 4 over 1. And -3 plus y2 over 2 is equal to -6 over 1. We can cross multiply and solve. When I do that, I'm going to get 8 equals 2 plus x2. That means 6 is equal to x2. And so let's put in 6 here. And then this is going to give me -12 equals -3 plus y2. -9 is equal to y2. So I'm going to plug in -9 here. Next, let's scroll back to make sure that this point agrees with what we have. And 6, -9 is right where we thought it would be. It would be right here, so we know that our work is correct. Okay, back to more problems using geometry. This is leading into proofs. We're not to proofs yet, but this is what we will have to do once we start to prove problems. Measure of angle BXE. So I'm looking at BXE, that's that obtuse angle, and EXF. Hopefully you can see that that's going to, it will cover a straight line, so there's going to be 180 degrees. So we're going to say that you add those two angles up, it equals 180 degrees. And so you could say linear pair, you could say adjacent supplementary angles. Let's write in linear pair. I would even take, if you said angle addition postulate, because we're adding up angles. Although it's not equal to, well, yeah, it is equal to that third angle, because our third angle is just a straight line. Next, we have the distance of AX plus the distance of, and that's going to have to be XE, is going to equal AE. And so we're adding segments. Segment, addition, and then postulate. Alright, next. If BF bisects AE, and let's just pause right there. I'm going to put a little star here. The reason why I did that is this is not drawn to scale. And why would I make note of that? Well, look at our drawing. It says that if BF is going to cut AE in half, well, clearly AX is much shorter than XE. But in geometry, they will do that to you. They will make something not drawn to scale just to try and throw you off. So we just have to be aware that even though it's not drawn to scale, these two sides, or these two segments, are each congruent. So X is the midpoint of AE. And the rule is going to be definition segment bisector. Alright, and the reason why the rule is segment bisector is that's what's happening here. Segment BF is bisecting segment AE. So therefore my rule is going to be definition segment bisector. It's not definition of midpoint, okay? Because as a result of BF bisecting AE, then X is the midpoint. But that's not my rule, okay? The rule is going to be definition segment bisector. Next, if X is the midpoint of BF, then I can say what? Well, I can say that these two lengths are both equal. So let's say that BX equals FX. And what do we do here? We have drawn a midpoint. So we're going to say definition midpoint. Next, if XC is equal to XD, then XC is also congruent and equal to XD. That's definition of congruence. That's an easy one. If something is equal, it's always going to be congruent. 19, measured angle EXD. So EXD is this angle here. Let's put an angle 1. Plus the measure of some other angle is equal to measure angle EXD. So they want this entire angle. So for right now, let's just ignore this ray. Let's pretend like it's not here. Okay, so we're going to say that angle 1 plus angle 2 is going to equal this entire angle from E to X to D. So that would be angle DXD. And that would be, we're adding up angles, so angle, add, and then postulate. Next, if X is the midpoint of AE, and again, let's put a little star here, not drawn to scale, clearly not drawn to scale. Then AX is congruent equal to XE, and what do we do? It's same here to draw a midpoint, so we can say definition midpoint. That's all for coordinate plane. We'll see you next.